Hello everyone, my name is Leon Junlong and my matching number is 202371. And now I'm going to present our topology for lab 9. So this is our topology. First, we use the normal router doesn't have the serial slot. So what we have to do here is we go to settings and we add a serial slot for it. And same for all three routers. So we add the slots. So it will have a serial slot to connect with the serial. So this is our topology. Then I will start with the lab. So first we configure the environment first. We just change the system name for the router to R1. Then we configure the IP addresses for the serial interfaces. For R1, configure the IP address for the serial interfaces to 10.0.12.1 with a subnet mask of 24. And also same goes to R2. R2, these two, the serial 1 interface with IP address of 10.0.12.2 and a subnet mask of 24, and a serial 2 interface with IP address of 10.0.23.2 with a subnet mask of 24. And last goes to R3, interface serial 2 with IP address of 10.0.23.3 with a subnet mask of 24. Next, I will go to R1 and then go to and change the link protocol mode to HDLC in serial 1 interface. And do the same for R2 also. In both interfaces, serial 1 interface and also serial 2 interface. And do the same also for R3 at the serial 2 interface. So next step is to check the interfaces by using the command display interface serial 100. And as we can see here, the serial 1 interface is up and the line protocol is up, and also the link layer protocol is HDLC. So now we will try to ping R1 from R2. Right here, 10.0.12.1. So as we can see here is successful, and ping R3 also it is successful. Next step is we need to enable the OSPF for 3 routers. By using this command, OSPF1 area 0, and then set up the network address, and do the same also for R2. And then for R3 also by using the same command. So next, we show the routing table. So the routing table in R1, and as you can see here, there is a destination address of 10.0.23.0 because this is actually an address for R3, but because we enable the OSPF, so the address can be shown here at R1. So that is all for me. Thank you.
Okay, can you guys see the command?
Yes.
Okay. So my name is Lim Yong Kin. My matrix number is 203519. So I will be continuing for the configuration PPP. Okay, I will start with display using the display this command in each interface to show the link protocol mode has already changed from HDLC to PPP. So for in router 1, the interface is 0, 1, 0. So I'm going to display this in this interface 01. So you can see the mode is the link protocol is PPP, and then the IP address is 10.0.12.1. And then same goes to router 2. For the display, okay, for the interface 01, the link protocol is PPP and the IP address is 10.0.12.2. And for the interface 02, the link protocol is also PPP, and also the IP address is 10.0.23.2. And then same thing in router 3. Link protocol PPP and the IP address is 10.0.23.3. Okay, so I'm going to test the connectivity using router 2 as an example. So I'm going to pin it to to router 1. So it shows success, which can confirm that all the modes in the routers are the same. So if the routers are not the mode are not same, then the connectivity will be failed. So in case of you pin fail or anything, make sure you check the interface and make sure the protocol is PPP for all the routers. Okay, that's all. And then I will move to the next part, which is check the routing entry. So I will be using router 2 as an example so that the routes to R1 and R3 can be seen. So, okay, I'm going to type the display IP routing table. So a little different from HDLC is that after configuration of PPP, the interface will have its own interface IP address and a 32-bit mask. So you can see this is the IP address for the interface 01 in router 1, and this is the IP address for the interface in router 3. Okay, after the and then the additional question for this part will be covered by Machiong later. So I'm going straight skip to PAP configuration. So PAP configuration is to increase the security in the router. So in order to access to the router, you have to type the username and the password. Okay. I have personally done the configuration in the router 1, so I'm just going to show the result. So display this. So you can see the PPP authentication mode is PAP, and then router 1 will be used as the authenticator. So to show this is the authenticator interface. So you can see the username I have changed to my own name, YKin, and then the password is actually YK99, but it's here show it won't show it out lah, so it people wouldn't know your password, only you yourself will know it. Okay, so and then same in router 2, but only in the interface 01. Display this. Okay, you can see the PPP, PPP authentication. No? So the username is YKIN and the password cipher also YK99, but it won't show here. Okay, now I will do I will show the detailed flows of the link between router 1 and router 2. So I will shut down the interface first. I will shut down the interface 01 surface. Shut down and then undo, shut down. Wait for a minute. Okay, so you can see here, after I type the undo shutdown, you can see this is the input, which means input, router 1 receive an input from router 2 with the code request. So router 2 use code request to request access to router 1, and then, sorry, okay, and then router 2 will then show and give an output to router 2 with the code acknowledge ACK02. So which means it acknowledge the access request from router 2. Okay. Okay, that's all for my part. I will pass it to Edwin first, and then Chiong. Thank you.
Okay, wait for a while. Can you guys see my slide?
Yes.
Okay, my name is Edwin and my matrix number is 202884. And due to low network connection, very weak network connection, so I'll be stopping for the video. So I will just stop the video and I'll start presenting for step 10 about chat authentication between router 2 and router 3. Okay, so first of all, for step 10, we need to establish chat between router 2 and router 3. So first we go to router 3 and we go to interface 002. Go to, after you have entered serial 002, you need to set the authentication mode to chat, because before this, the authentication mode is PAP. So you quit it and you put AAA. This AAA means that R3 is the authenticator. And next, we'll need to set for the user, for the username and also for the password. So local user admin password cipher admin123. So next, we'll need to set the service type that is provided for the user. So here, local user admin, service type is PPP. Then we quit from here. Then later, we enter interface 0002 and shut down. After shutting down, we undo the shutdown again. And here you can see that the authentication is filled and PPP link was closed. This is because the chat was disabled on the peer. So this is because we haven't configured the chat at router 2. So even though it restart again, it can't establish the connection. So we go to router 2 we go to the interface serial 002, router 2, interface serial 002. Then we type for the username and also for the password. Wait for a while. Okay. Interface 0002, type for the username admin and also the password. Password cipher admin123. So next we'll try to ping to 10.0.23.3, which is the router ID for router 3. So to test that the link between them is established. So you can see that this 5 packet is success. So next we will try for the chat debug. The next step will be PPP chat debugging. So at router 2, we go to interface 0002 and we shut down this interface first. Later we will debugging PPP chat all of the debugging about chat, and also terminal debugging so that it will appear at the terminal here and then display those debugging at here. So we need to undo the shutdown because at the above part we already shut down. So go back to interface 0002 and undo shutdown. And you can see that here it will present that from initial you go to listen challenge, and this is actually the challenge from sent from the authenticator. So from here you can see that R2 is input because this is received from R3. So code challenge is 01. And next it will router 2 will create the response. Will create a response. Okay, so you can see that here the router 2 already received challenge event, then it will output the response. So the response code is 02. And next it will change from listen challenge to send response. So after sending response, R3 will reply with acknowledgement. So at here it is input and the code is success for 03. And here you can see that it receives success event. So from send response, it become client success. So which means R2 already successfully connected to the authenticator R3. So lastly, we'll need to undo the debugging all. And that's all from me. I will pass the time to our leader, Chiong. Thank you.
Okay. Do you guys see the slide?
Yes.
Okay. My name is Machiong and my matric number is 20338. And I am the leader for this lab 9. And now I will show the answer for the addition question. So for the first question is the thing about the origin and function of the two router and check the following item. If the HDLC encapsulation is used, do these two router exist and capture the result? So we can see for this, I already captured the comparison for the HDLC and the PPP routing entry. So for the HDLC and the different things between the HDLC and the PPP routing entry, we can see for this is the HDLC routing table and the right side is the PPP routing table. And actually just now Yongki already explained for a little bit different. So now I will recap again. So for the HDLC routing table, we can see if we type the display IP routing table, we can see for the series 001 and the 001 have the 2, and also the 002 have the 2 destination in the routing table. And we can see the IP address is 10.0.23.2, and another one is the 10.0.23.0. And we compare with the right side, we can see for the series 002, we can see actually they have one more. The destination is the 10.0.23.3, which and the SUNET mask is the 32, which is this router 2, the destination. This destination IP address is for the R3, which is the R2 connected. So we can see in the R2 routing table, we can see in the 10.0.23.3 and the stress and the SUNET mask 32, and also for the another one is the 001. We can see the 10.0. The different add one more is the 10.0.12.1 and the stretch 2032 is also this is for the router 1 and connect to the router 2. So this is the different thing, and we can see the behind one, the dot is the point. So for the PPP, the IP routing display IP routing table, we can see it will show the point to the neighbor, which is the R1 and the R3. And for the HDLC routing table, this will not show the neighbor with the point. So this is for the question 1. And for the question 2 is we try to can the R1 and the R2 communicate using the HDLC or PPP when using the IP address for the S001 on the R1 and R2. The important thing is the different locate on the different network segment. So in order to solve this problem, we need to create a new topology. So this is to make sure the R1 and R2 is can work in the different network segment. So now I will show the and this is the new topology for the between the R1 and the R2. So I didn't change the name. So the R1 equal to the R5 equal to R1 and R6 equal to R2. So now we see how about is it the work on the different network segment between the two routers. So before this, we prepare the environment. We set it for the R5, and we put it the IP address for this router is 10.0.12.1, and we see another router is we set out the IP address is 10.0.23.2, which means is the different network segment. So we continue to see. So after we done the configuration for the network segment and the IP address, we set up the link protocol for the HDLC. After this, we confirm whether it is success for the configuration of the HDLC. We can type the display interface series 001, and we can see this is the link layer protocol is the HDLC. So after this, we turn to the router 2. And also we set the link protocol HDLC, same with the R5 just now. And after we set up the HDLC and we try to ping up for the IP address for the R1, so for the R5, so we can see if we ping the IP address 10.0.12.1, the ping command is no success, request times out, and it's the fail. So the while fail with the communication between the different network segment because we haven't done the OSPF protocol. So in order to can be success, we do the OSPF protocol. We go to R5, we set out the OSPF1 and the default area is the 0. And we set the the network and also the network and the network segment, and also with the SAN mask 0.0.255. And okay, we done this. And also for the router 6, we do the same thing for the OSPF. We set a OSPF1 and the default area is 0 and network. And we set out the network segment is the 10.0.23.0, which is for this router 6 and also the SAN mask. And after we done the OSPF, we can see after we done OSPF, we can see we pin again for the 10.0.12.1. This result is a success after we done for the OSPF. Although the R1 and the R2 is located on the different network segment. So for this, after we done the link protocol for the HDLC, and we do again for the PPP. So for the PPP, we set out the link protocol PPP. And after we set up, we check again whether the link protocol is it changed already or not. So we type the display interface 0001, and we can see the upstate and the link layer protocol is PPP. So, and also do the same thing for the router 6. We do the PPP. We do the link protocol PPP for the router 6. And after we done for the PPP, and we try to ping again whether it's affect the result or not. If the link protocol HDLC changed to the PPP, so we try to ping again for the 10.0.12.1, which is the IP address for the R5. So the result is the same, same as the HDLC. So PPP also the success. So for the last one is to confirm the IP routing table. So we try and we type the display IP routing table. We can see we already set up the OSPF for the 10.0.23.0, which is the IP address for the router 6. And also the router 6 is, we also type the same thing, and we can see the OSPF, the 10.0.12.0, and this is for the router 5. So this is for the question 2. So the answer for the question 2 is the CAN for the R1 and the R2 can communicate using the HDMI PPP, although the R1 and the R2 is located on the different network segment. So the third question is why is the PPP challenge handshake authentication protocol chart is more secure than the PPP password authentication protocol PAP? Because the CHAP is more secure because it will send the password through the link. We can see just now Edwin show the result. The CHAP actually send the challenge code to the neighbor, and the neighbor, if the neighbor want to connect with this router, he need to send the response code send back to the router itself, so that the router can confirm whether the password is correct or not. So for the PPP, why not the PPP is not more secure than the CHAP? Because the PPP, they send the link, they send the password through the link. Although the password already ciphered, so the others user don't know the actual password. Just now shown by the Yongki. It's shown on the cipher mode. So for this explanation, we know that CHFP is more secure because the other people don't know the challenge code between the router and also the response code between each router. So this for the answer for the third question. So next is the mind map for the lab 9 for this lab. So for this lab is the first one is prepare the environment. So prepare the environment, we can see after we prepare the environment, we set out the name for the R1, R2, and also the R3. So after this, we configure the serious interface IP address, which is the 001 for the R1, 001, and 002 for R2, and so on. So after we done for the IP, set out the IP address for each router, we enable the HDLC protocol. So we set out the link protocol HDLC. So after this, we set out this, we configure the OSPF between the R1 and the R3 so that the R1 and the R3 can communicate. So we emphasize the remote network between the R1 and the R3. So after this, Jinlog already do this one and verify the configuration for the OSPF. So after we done the configuration for the OSPF, we do the configure the PPP on the serious interface. So we do the PPP because just now it's HDLC and now we change to the PPP on the serious interface. So after we change to a PPP on the serial interface, after we done this, if the result is not being operation, it failed between the R1, R2, and the R3, we check the link layer protocol whether the HDLC already changed to PPP because the different protocol cannot ping to each other. So after this, we check the routing entry and compare the HDLC routing entry. Just now I already showed the comparison for HDLC and the PPP routing entry. So next is the enable the PAP authentication between the R1 and R2 is done by the AV. And next is the enable CHAP authentication between the R2 and the R3. So next is the last one is the run PPP CHAP debugging. So I think that's all for this lab. So thank you.